Okay, so we're going to be dealing with more assemblies now. We're going to talk about more techniques, assembly techniques. And if you've been following this video series or on the website, you'll remember that we just put together another assembly, a very simple one, called the hammer, which consisted of the hammer handle as our fixed unit, the first item we put into the assembly, and we put the hammer head on top of that, and we created the hammer assembly. So we covered a lot of the basics in regard to putting an assembly together. And in this video, we're going to talk about some more options that we could use in order to put together a little bit more complicated assembly. And this assembly ultimately is going to result in a movable part, into a movable assembly. There are going to be components, movable parts within the assembly that we're going to be able to use and manage and manipulate. And it's actually kind of fun. It's called the Sarrus Mechanism. So the way we initiate this is we want to go to File, we want to go to New, and we remember the three different files you can create with SolidWorks, and just three. You have your part, your assembly, and your drawing file. And just real briefly, because we covered this in our hammer assembly video, assembly is reliant upon a part in order to get an assembly together. The same thing with the drawing too. So this is actually the second file we're going to be using here in SolidWorks, and this is kind of a second introduction to it. And we're going to go ahead and click on the assembly. Right now I'm in the novice mode, and if you're in the advanced mode, you might want to click on the novice button for that. And if you have already template files already created, you might want to go to the advanced button over here too. So we're going to go ahead and double click on that, or just go to OK, and it gets us open, puts us right into the assembly. Just like with the hammer, we're given a folder that maybe the folder we were in last, in order to get some of the parts we might want to put into the assembly. And just like with the hammer, we need to consider what is the first part we're going to put into the assembly. And with the Sarrus mechanism, it is going to be the base plate. But just to give you a little tour here, right away, just like with the hammer, it opens this up and gives you the opportunity to put in that part, because you can't really do anything else until you get a part in here. So I'm going to go to a different folder up here. I'm going to go up to the top level up here. I have a folder for videos. This is going to be our week 5 videos. And we're going to go into the folder number 29. And we have 7 parts that we could choose from in here. But what we're looking for is the base plate, the Sarrus base plate. So we're going to go ahead and double click on that. And just like with the hammer, if we had our origin on and showing, we could actually drop that right on top of the origin. But the best thing to do here, since we want to line up the planes, and I describe the importance of lining up planes and lining up the origin for that first part. I explained that in a hammer video, so I'm just going to go right to the green check mark, and it puts the origin to the origin together, and then it lines up the front plane to the top plane to the right plane of the assembly to each of those corresponding planes in the part too. So we're going to go to the green check mark, and it puts that into place. So again, just like with the hammer video, we talked about the similarities between our assembly and parts. We have the history folder, sensor folder, annotation folder. We have our 3 front planes which intersect at the origin. Then we have our part that we put in here. And one thing you'll notice about that part is it's got all the components that we had in here. It has all the features, and we could actually go inside this folder and actually make edits to it, as was described in the hammer video. But one thing that's new in here, just like with the hammer video, is we have our mate folder, and we don't have anything in the mate folder yet, but as we begin to put more parts into our assembly here, that's going to get filled. And we're also are going to have a mate folder in regard to each part too. Don't have that yet, have no mates yet, but we have our first part in here, and now we're ready to go. Okay, so now that we have our first part in our assembly, I typically like to save this, and I like to save my assemblies of parts early and then save them often, kind of like what they say about voting sometimes. But what you want to do is you want to go ahead and save this under the assumption that if you've already created all 7 of your parts for your Sarrus mechanism, you want to make sure you save your assembly within that folder too. So we're going to go to File, Save As. I'm going to go ahead and put that in. And I have a kind of a special name I use, but give it a name that it's going to be easy for you to find. And we're going to go ahead and go to Save. And it might give you a window in here if it's an earlier version of that part. Right now I'm saving in 2017. If it's an earlier version of that part, like 2016, one thing you want to keep in mind is it's going to go ahead and rename that part. Not necessarily rename it. Sorry about that, but it's going to go ahead and save it with that existing name under the newer format, under the newer SolidWorks version. But you can't go back. If you're saving it 2016 and 2017, you can't open it up back in 2016, so keep that in mind. Okay, so let's put in our second part. If we go up to File, there's a couple of ways we can do this. If we go to the pull-down menu, or the menu bar up here, if we go to Insert, we can go to Component, and slide over here to Existing Part and Assembly. Or we can go to a new part. We can design a new part within the assembly itself, but we're going to cover that in a different video. But the typical way of doing it is a little bit bigger button, and I think it's one less step. If you go to the Assembly tab over here in the Command Manager and go to Insert Components, that opens up this property box over here, the Properties Manager, and the yellow box up here means we need to begin to select some items in order to get this fulfilled. Of course, if it's right up here in the message box, it means you're doing something wrong. If it's green, it means you've got everything satisfied for that Properties Manager in order to move on to the next step. So it's kind of looking down here. It's not really light blue over here, but it opens up this dialog box, and it's probably going to go in the folder that we were in before, where all your Sarrus Mechanism parts are and now your assembly is. And what we're looking for over here is going to be the Sarrus wheel mount. So if you just click on that, maybe double click on it, we'll get it open. Or you'll notice there is an open button down here at the bottom of the dialog. It closes that dialog, puts this into the graphics area, and it follows your cursor around. You'll notice that. And now we have that part populated over here in our selection box. So we're not going to worry about some of these options down here. We're going to keep the default settings, and we're just kind of drop it. Usually I just drop it off the side of the first part so it doesn't interfere with that part, or maybe pick up a relationship that we don't necessarily want. Kind of like what happened in the sketch environment. But I don't think we're going to be able to pick up any sort of mates out here automatically. But if we go ahead and drop it out there, now it kind of puts it out there. So remember the first base plates that we put in there, we went through the effort of making sure we define that to the origin. That so that all the front planes, all the primary planes line up, the front to the front, the right to the right, and to the top get all lined up here. And we explain that a little bit more in a hammer video. But with this part that we put in, our second part that we put in, we want to float that. So if you take a look at this over here in our Feature Manager, you'll notice that the first part has got that bracketed F, which means it's fixed. This one's got a negative sign, which means we haven't fixed it yet, which means it's got a lot of flexibility here. Now when you're dealing with a sketch environment, typically that would mean that there was something wrong with your sketch, you want to fully define it. But in an assembly environment, that may not be a bad thing. We're going to cover that here in just a bit. So now we're going to go ahead and mate this. Just like we did with the hammerhead, we're going to go ahead and apply some mates in here, but we're going to do this relatively quickly. There's going to be 3 mates we're going to be able to put on this wheel mount, and we're going to initially take the bottom of these feet here and mate it to this surface in here inside that slot that we made. And we're going to take this edge, not an edge, you got to be careful about this. And this is an evaluation question too. You don't want to necessarily choose edges in here. You want to choose surfaces if you can. So we're going to mate surfaces to surfaces. We're going to take this surface over here, mate it to that surface over here, and then the front surface over here and that foot to this surface in here. So it takes a little bit of manipulation of moving your model around in order to get that in place. As we move through this assembly video, I'm going to show you some shorter techniques that we could use. So we're going to go up here to the Mate button. We've already put in our Insert Components, which is the second button over here in the Assembly tab in the Command Manager. Mate is going to be the next one, so we're going to begin to populate our Mate folder in here. So if we click on Mate over here, very similar that we've seen before in parts. Gives us our Property Manager, and it gives us the capacity to come in here and add some elements in here and change some options. First thing it's looking for is its entities to mate. So we have our selection box over here, so we're going to go ahead and select on this surface. You notice that the primary part that we clicked on here, which is our fixed element of the first part that we put in here, the base plate, that kind of turns transparent and gives us the capacity to now concentrate on the part that we haven't selected yet. So we're going to go ahead and select on this surface back here in order to do that. You notice that it automatically just kind of goes ahead and gives us a preview of what we're going to be getting. Doesn't really solidify that until we go to the green check mark. And we go to the green check mark here in a couple different places. There is a shortcut menu over here which reduces your mouse travel, which is pretty close to where your cursor is going to be. And we can go to the green check mark over here too. So let's see what we did. It's still, and if we go to the green check mark over here and we go to mates, kind of get out of that, and the mate property dialog is still open. The property manager is still open there for our next mate. So it's kind of thinking that we're going to add like maybe at least 2 or 3 consecutive mates together. Kind of reduces the amount of time we're going to be spending here modeling. So it keeps that open for us, which is convenient. But if you take a look at our model over here, our feature manager over here, and take a look at the parts we have in here, we again have the fixed part for our base plate. And this one's got that negative sign on it, which means we still have motion. What we cannot do with this right now is we cannot move it about the y-axis. So we can move it about the x and the z-axis, but not the y-axis. So now we're going to go ahead and continue on with mating this. We can select elements in here first. Remember surfaces, we're going to go ahead and click that surface. And this surface with the control key depressed. And if your shortcut menu pops up quick enough, here's your mate button over here. You can actually select that and it's going to put that in place. Green check mark. And it's still open here, so let's go ahead and define our next one, which is going to be that surface here. Turn this around. We're going to click on this surface, put that in place, green check mark, and now we're ready to go. If you go ahead to the green check mark one more time, or Control B to rebuild, now you notice that the bracketed minus sign is not there, which means this is fully defined. So let's go ahead and take a look at this real quick. The first element we put in here, the base plate, if we were to click on that surface and try to move it around like you would normally with a part that's kind of loose, like we did with the wheel mount, it says that the selected component is fixed, it cannot be moved. And if we select on this one over here, our wheel mount, says the selected component is fully defined. It cannot be moved. So there's 2 ways to make sure that your elements don't move inside of your assembly. You can fix it. You can fix it in an arbitrary location, or you can define it to an element that's already fixed, which is what we did here. Okay, so now it's time for our third component. Our third component is going to be the Sarrus hinge plate. And initially we're going to put in a hinge plate here in the bottom, virtually glue it to our existing part that we have in here, which is going to be our base plate. And we're going to mate it in a very similar manner that we did with our wheel mount. We're going to put it on this surface down here, and then we're going to make a relationship with that surface over here on our base plate. And then the surface that's right behind this wall over here too. So let's go ahead and do that. Let's go ahead and open this up. Let's go to Insert. We can go to Insert and go through this. We can go to Insert Component, Existing Part in Assembly. But the easier way to do that, of course, is to go to Assembly and then go to Insert Components up here. And we can go ahead and choose what we want. So we're going to go ahead and scroll down. We're going to go ahead and pick the hinge plate that we have over here. And I have one over here for configurations, but we're going to cover that here in just a moment. But if we go to Open, we're going to go ahead and drop that in an arbitrary location out here. You can see our Properties Manager is open with the capacity for us to select over here and make various optional changes. But we're just going to drop it out here in an arbitrary location and call that done, at least for now. So let's talk a little bit about dynamics in here, about degrees of freedom. When you first put a part in here, it's considered floating. When you have no constraints in that part, it's got 6 degrees of freedom. And remember that, that's an evaluation question, which means it has the capacity for you to move it down here to be able to move it up and down, translate it about the y-axis, about the z-axis. It can translate about that too. And about the z-axis, actually it'll translate about the x-axis over here. And in this direction, it'll translate about the z-axis, as you can see on the triad. But it also has the capacity to rotate. So the translational capacity here, your 3 degrees of freedom over there, translates about the z, about the x, about the y. But we could also rotate about those elements over here too. So instead of move component, if we go to that pull down arrow up here, we can go to rotate component. So this way we can rotate it about the x, y, and z also. So the 6 degrees of freedom translates about the x, y, and z axis. And the other 3 degrees of freedom are going to be being able to rotate about the x, y, and z axis. And of course, every time we put in a constraint in here, every time we make a mating relationship in here, it begins to narrow down those 6 degrees of freedom to the point where it's going to be fully defined. In this situation, it's going to be fully defined, but the other hinge plates we're going to put in, we're going to limit some of those degrees of freedom so it does have the capacity to rotate about one of these axes, and I'll explain that a little bit further as we get there. So let's do this. Let's go ahead and select on this surface and rotate this down. We're going to go ahead and select on this surface. We're going to select these items first before we go to mate. And you'll notice this is really convenient here, where that first surface that we selected, that part it's associated with that goes transparent, so we can see what we're doing here when we're clicking that opaque surface on the existing part, that second part that we're making modifications to, that we're manipulating. So we're going to click on those surfaces there, and if we like what we see, and I do, we're going to go to the green check mark and put that in place. Now we're going to define this a little bit better. So again, just to kind of reiterate this, it still has the capacity to rotate about the y-axis. So we're going to continue to add mating relationships in here. Maybe this surface over here, scoot out a little bit. This surface here, we're going to put that together. And now it kind of rotated it so it can be in place. So the last bit of flexibility that it has is only translational about the x-axis. So what we want to do is we want to go ahead and select this surface here and go to Mate. And then here's a different way of doing it. Instead of rotating your model, you can right click as if you're selecting that surface through this this surface on top. If you were to right click on that and go to Select Other, now it gives us a short choice of the different items we could choose from that get intersected by that cursor, where the cursor is resting. So that first one is going to be this one. So if you just right click on it, select Other, and click on this space here, now it's going to go ahead and make that mating relationship in there. And just like before with our wheel mount, if we were to click on that surface of that hinge plate and try to move it, it says the selected component is fully defined and it cannot be moved. So that's fully defined. You'll notice that that minus sign that we had over here in our Feature Manager is now gone, and now we're ready to move on to our next step. Okay, before we move on, let's go ahead and put in one more hinge plate. And one easy way of doing that, and let me show you two different ways of doing something fun and easy, is we could actually select that hinge plate that's already in place here, and with the Control key depressed and dragging it out, look at that, isn't that cool? That's really kind of fun. You can do the same thing over here in Feature Manager over here. You can actually grab that part over here and drag it over here too. So what we want to do is we want to maintain relatively the same orientation we had before. And when we put in this hinge plate here, it'd be nice to have the rounds and the cuts over here too, so we don't have to rotate this. It takes a little bit of time to do that. And over here, it's actually going to resolve itself pretty quick over here too. So this one, we need to do some more stuff to. This one we could probably put together, but you're going to be able to see right now that when we put these together that we're going to have to do something about the rounds back here, because it's going to interfere with the hinge plate that's going to be over on this side. And we need some rounds and cuts over here on this side over here, but we don't need them on these sides too. But let's go ahead and mate this together. Let me show you how we can make a mate in here that doesn't necessarily get fully defined. So the first thing we're going to do is we're going to go ahead and click on this surface. Make sure you click a surface and not an edge. I mean, it's real easy to select edge here. A little bit harder to select the surface, especially if you're further away, but you got to make sure you click on a surface. Surface to edge is probably okay, but surface to surface is always best. And the worst mate out there is a point to point. That's just going to trip you up. So let's go ahead and click on those two. And with the Control key depressed, you probably want to have that Control key depressed. Let's go up to Mates, and we're going to go ahead and mate that together. So now you notice that we went ahead and limited that quite a bit. Our degrees of freedom here, if we were to move that around a little bit, now is rotational only about the z-axis down here, and it's translational. So we've eliminated 4 out of 6. It's translational about the z-axis too. So now we can eliminate it even further. We can get rid of the translational portion of that on the z-axis by clicking on that surface over here, and maybe this surface over here, and go to the green check mark, and bang. Now we have that in place. So now it's only rotational about the z-axis. This one here we can't really do much about. We need to have those hinge rounds in here, and we can conceivably rotate this around and do that. But I like to try to maintain as best we can the orientation of the part we put into an assembly to the orientation of the assembly itself. So we're going to come back and we're going to go ahead and make configurations of our different hinges that we have in here, or hinge plates, and then we'll come back to this model and finish this up. But let's go ahead and go to the green check mark and take a look at our Feature Manager here tree before we leave this. Of course, the first component's fixed. This component over here, if you rest our cursor over there, you can see that over here. Kind of got you see the envelope around that. Kind of gives us a orange preview there. And then this one, the hinge plate, the first hinge plate we put in here is also fully defined. It doesn't have a minus sign next to it. So, and then these two other hinge plates have motion. This one's got a lot of degrees of freedom, but this one on the right has been reduced down to only 5 degrees of freedom, of which the last remaining one is rotation about the z-axis. Okay, so we're going to take a break from the assembly here for a bit, and we're going to go ahead and open up our hinge plate part. We're going to make different configurations of that hinge plate. So the way that works, the way configuration works, and that's going to be an evaluation question, is that you want to, a configuration is like a part within a part. So we're going to be taking some geometry that you have in here, which is going to be the plate to the same thickness. It's going to have that hole in the middle. And then the different configurations are how these hinge rounds and cuts actually rotate around the part. So we're going to keep some, we're going to delete some other ones, and we're going to make a cut in the back. So we're going to be creating that part within the part, that configuration, which is going to have all the hinge rounds on it for one. We're going to have a back and a right one. We're going to have a front and a back one. We're missing a front one here, but we're going to have a back one over here. And then we're going to do another front and a left one. So those are going to be 4 configurations. I'm going to do a derived configuration where we're going to take out one of these hinge rounds and cuts over here on the right hand side in order to accommodate the push rod that's going to come off the Sarrus wheel. So join me for that video, take a break, watch the configuration video, and then we'll come back here to the assembly in just a few minutes. So let's go back to our assembly and see what we've done, and the desire here was to take our hinge plate, make configurations of that, so we could take out some more of this stuff, so we don't have so many hinges and hinge cuts in here, but kind of looks like our hinge rounds and our hinge cuts are like there's more of them than less, but that's okay. We're going to go ahead and fix that. But let's go ahead and take these two components in here. Let's just go ahead and delete those. We're going to reinstall these back into our assembly the old-fashioned way. But this one we could probably make a change. And the way you would do that is you would actually click on it over here, and it would give you the different configurations that you have. Or you could right-click on it and go over here to Properties and do the same thing. So you could go over here and go to the top up here, this bar up here in the top, and pick the one you want. So back and right is going to be the appropriate choice. And then we can go to the green check mark over here, and that should put that into place, which it does. So let's go and insert our hinge plate yet one more time and bring that into the modeling area. So, the way we've done that before is we go to Insert Components, and we have a lot of hinge plates in here, but we're going to choose this last one down here, and we're going to install that. And over here, before we actually drop that into place, now we can choose our configuration that we want. So this one we want to do regular old-fashioned front-back. If you do that, now you can see that that's what we have. We're going to go ahead and drop that into place. And it's out here arbitrarily, so we can still rotate it, we can still move it around. And as an alternative to that, we're going to go ahead and take this one over here, which is our last one over here, and with the Control key to press, go ahead and drag that out over here. And now we can pick the derived configuration in this one. So if you were to click on this, go to the configurations up here, a list of configurations. Now we don't see it. For some reason, it's not showing us the derived configuration. It should. And it's not giving us the check mark over here either. So another way of doing this, kind of the old-fashioned way of doing this before 2016, if you were to right-click in this, we can go over here to the Properties, Component Properties, and click it over here. So here is the front-back hinge cut. And then we're going to go to OK. So we're going to make sure we have that hinge cut up here on the top. Okay, so now you notice that these configurations still have that sketch involved over here. So we could take that sketch and tell that to hide that. We're going to go ahead and hide that for each one of our configurations because we don't really need that now with our assembly in place. And once you do that, when we reinsert that configuration, that front-back configuration of the hinge plate with the back hinge cut, that sketch will now be disappeared. So if we were to actually open up that part and look at that configuration of that part, the sketch will be hidden, as it should be when we're in the assembly, as we are right now. So let's go ahead and rotate this. Let's go ahead and start putting these in place again. And we're going to go ahead and choose the surface. Remember, the surface is always best. And maybe that surface, if you can get something that's adjacent to it, that would be good. The Properties Manager is still open for mating, so we're going to go ahead and choose this surface over here. Actually, let's go ahead and choose this one over here. Oh, yeah. This is tricky sometimes. Sometimes you assume that it's going to go ahead and do the green check mark and go ahead and put that into place. But we have to physically do the green check mark before we go on to the next one. So the green check mark will embed that mate into our model. So we're going to go ahead and click on the surface, and that surface, green check mark. Now we have that in place. And now we have that cut for the push rod when it comes off the wheel on the Sarrus Mechanism. So let's do this. We still have the Properties Manager open for mates. Let's go and click on the surface, not an edge, but the surface. Let's go and put that into place. Green check mark. And this is a pretty easy surface to select, the edge of the hinge plate. We're going to make that mated. And now we have that in place. So move that up a little bit and go to the green check mark, and that gets us out of mates. Okay, a few more hinge plates. Let's go ahead and take this hinge plate over here, which has got the back cut. We want to go ahead and take that in and put this into the model and rotate it so that we actually have the complementary cut on top of this hinge plate that we have here. So we're going to take that, we're going to do the control key and drag that guy out. And now let's go ahead and rotate this around. So if we go to move component, go to that down arrow over that or under that, go to rotate component. Let's go ahead and rotate this guy around and put that on the bottom. So we want to have that complementary cut over here. So once you do that, go to the green check mark, click on that surface over here to mate it. That surface, we're going to pre-select that, go to mate, put that into place, green check mark, don't forget that. It's easy to do, I do it all the time. We're going to go over here, go to the green check mark, and now we have that in place. So now we have some compound motion in here. And yeah, we can move that around a little bit, put that bend in there. And depending on how we do this, let's get out of mate over here. We're going to go to X over here. Depending on how we do this, we want to have a little bit of a knee bend in there. So keeps on trying to straighten out here. Let's try to move that a little bit. So I think that'll work. And then we'll go ahead and grab a section over here and put that in place. So that's kind of what we want to do over here. We want to get that a little bit of a bend in there. We're going to do the same thing back here. But let me show you a different way of doing this. We're going to right click on this. We're going to tell it to open up that configuration. And now we're going to take this configuration, this hinge plate part of that configuration, front and back. We're going to go ahead and put that over here on the right hand side. And we're going to take our assembly and put that over here on the left hand side. And now we're going to put these together too. So we could actually move these around a little bit, maybe shrink that down a little bit, make the assembly a little bit bigger. So now we have two windows we could use in order to insert our parts. So we're going to take this guy, we're going to drag this over here, and this one's going to be the regular old front back that we want. So we're going to go ahead and apply the mates on that. And now that we've done that, we can go ahead and close this out. And we're going to say no here because it always can save it within the assembly. So when you have a situation like that where it's asking you to save the part, if you say no, you're going to get this dialog box for the assembly which says you want to keep the changes you made over here and incorporate that into the assembly. And if the answer is yes here, go ahead and keep the changes in the assembly. But if you don't want those changes, you're going to go to discard, and personally I don't think we made any changes, but we're going to go ahead and keep. So that way when we save our model a little bit later, it's going to go ahead and save the part and the assembly at the same time. So same thing we did before, we're going to go ahead and select that surface over here, this surface over here. We're going to go ahead and mate it, so we're going to go ahead and put that in place right there. Go to the green check mark. Save ourselves some mouse travel. We're going to do that over here too. Go to the green check mark. Now we have that in place. Let's go ahead and maneuver that in such a manner so it's got a little bit of that bend in there. Sometimes you're going to have to change the orientation of our model to do that, or select edges or vertices in order to get that lined up. So that's our assembly so far, and what we're going to do is we're going to put in that top plate, that top hinge plate, in order to tie this all together. Okay, so now we're going to put the hinge plate on the top. Now conceivably, maybe it's a misconception to use the same word, we could actually take this part over here and copy that and bring that up straight up and actually put that into place. But if you take a look at that, we're going to have to flip that a little bit. So you'll notice that if we were to put that together, where we have the cut over here is going to be the very same place where there's a cut over here. We're going to be putting kind of a substance where a substance is. And the same thing over here where we have that hinge round over here. It's going to interfere with this hinge round over here too. So that doesn't quite work. And conceivably, again, a misconception, perhaps, we could rotate that around and maybe do it this way. But it kind of lines up over here, but it doesn't line up over here. It's like exactly opposite. And that's why we put in that last configuration. So if we were to take that part, right click on it, go to properties, or actually just click on it itself, we can make our choice here, which is going to be our front left configuration. And we can right click on the mouse or go to the green check mark over here. And now we can do that way. So let's go up here to move, rotate that around. Because what we did is we actually took that part and flipped it. This is going to be kind of a mirror image of this on the bottom, or right through the center plane. So we actually flipped that around. So now we can actually put this together. So go to the check mark over here or escape. And just like we did before, let's go ahead and mate this. We're going to go ahead and choose our items over here in the graphics area first. You're going to mate that together, green check mark. And then this surface over here to that surface because it's adjacent. Let's go ahead and put that together. And now this is the fun part over here. We're going to take this surface here with the properties manager open for mates over there. We're going to make that and go to the green check mark or green check mark over here, and then we're going to go ahead and select on this surface. Not an edge, that's an edge. That's a surface. Let's go ahead and put those together, and bang. Green check mark one more time gets us out of the property manager for mates. And now we can do our knee bends. Bing, bing, bing. Here we go. So now the next components we're going to be putting in is going to be the wheel, the push rod, and then our wheel guard. We're going to put that in there too. And then a little bit later in the video, we're going to put in our toolbox fasteners. Okay, more parts. This part's going to be quick and easy. Let's just put in the wheel. And one other way we could do this too, by the way, to put these things in is actually take your folder that you have these parts in and just drag it. It's going to be the Sarrus wheel. We're going to go ahead and drag that in there and take this back. And very simply, all we're going to be doing is we're going to be taking that surface here, this surface on our wheel mount, and guess what? We're going to mate those together. Bang. And we're going to go ahead and reserve the rest of the mates on this until later. So we want this to rotate, so that's okay. And we might want to have a distance mate between like maybe this surface and that. So let's go ahead and put that in. Let's go to mate. Let's go ahead and click on this surface. Click on this surface as an option, and you'll notice it's immediately going to be giving us a coincident relationship. But there's other things in here too we can do. You know, of course, we can make it parallel. You know, by default, it's going to be parallel. We can make it perpendicular. Guess what's going to happen? It's probably not going to like that, but let's try that for some reason. Let's go ahead and go to the green check mark. So it says that this mate will break. Add this mate and break other mates to satisfy it, which means, you know, mate's going to break this thing. Or you could add this mate and overdefine the assembly. And if we do that, and then go to the red X over here, and now you see the the big red caution sign. And if we go over here to our feature manager and take a look at what's going on here, we can see what we can do to fix it. So first of all, this gives us an opportunity to actually tour the feature manager tree again. We haven't talked about the mate folder in a while, but here's the mate folder over here. It shows all the mates that we put into our model so far. And the last two mates we put in, we had a coincident or a concentric relationship between those between the inside surface of the wheel and then the round surface that makes up the wheel mount. And we have that perpendicular relationship in here too, and they conflict with each other. So if we were to take one and suppress it, the other one prevails, and if you unsuppress that and do it the opposite way, it'll prevail here too. So one thing to note here, if we take a look at this is the mate that was in here first, so all of a sudden that becomes conflicted, and that's the mate that we put in second, and that's the one that gets a red X. I mean, they're both in conflict with each other, but the one that's being impacted that was good before and now is bad has got the yellow item, has got the yellow caution sign to it, and this one's got the big red X. That's the one that's actually violating the other one. So you'll notice that when we suppress one and unsuppress the other, that those different elements are going to change. So we can actually flip those by doing something like that, and maybe bring in this one back up. Actually, let's bring the perpendicular back up again, and then go ahead and unsuppress that one. And now you can see that the red X is now on the concentric one, because the last one, which actually worked, was this perpendicular mate reference, and that's the one being impacted by it. But yeah, this perpendicular one, let's go ahead and redefine that, and we're going to do that here in just a moment. But something else you'll notice about the tour over here in the feature manager tree is that we now have two parts that have those mates that are in conflict with each other. So one of them is going to be the Sarrus wheel, as you can see, and the other one is going to be the Sarrus wheel mount. And if you go inside of that, now we get a shorter folder of different mates that are associated with that. And these folders are going to be the same. They're not going to have the same elements in them. The wheel itself is going to have only two mates in there in that mate folder. And both of them are in conflict with each other here too. So there you go. There you have the mate folder for each part. So it might be easier to actually click on the part itself and find out where those mates are, instead of having going through the large mate folder that's part of the assembly. There are mate folders that are associated with the part that might make it easier to do some troubleshooting. So let's go to our perpendicular reference, and let's go ahead and actually redefine that a little bit better. So other choices in here, we can lock that in place if we want to do that. We can put a distance mate on it. We can put an angle mate on it. Angle mate's probably going to give us the same error as a perpendicular mate. But let's actually redefine the perpendicular one, which is where we were. But let's go ahead and at least make it parallel first. And then we could do the distance mate on that. So parallel will get it corrected, and the distance mate, maybe 1/2 inch, at least for now. And then we could probably make adjustments to that later as we put more parts into our assembly. Once we do that, go to the green check mark. Green check mark one more time gets us out of that properties manager for mates. And we're going to come back compact our feature manager tree a little bit. And then we're going to continue to add more components into our assembly. So actually looking at this, maybe that 1/2 inch mate in here probably isn't as good as it could be. One way to make a modification to that too, with the wheel mount in here in regard to that distance relationship, if we just click on that just briefly, we could actually make that change in here. So instead of 1/2 inch, maybe 0.2 inches. That way we don't have to right click on it and actually go into that mate and make that modification. Rebuild, compact our feature manager tree, and now we're ready to move on. Okay, so let's add more stuff. Next thing we're going to put in are our pins, and we're going to put in those Sarrus pins, and we're going to put them in on our hinges over here. And you'll notice that because this is a virtual model, and because of the mates we put in here, we don't necessarily need something that's physical in order to keep this thing from moving like you would have in a real world. And one thing that's notable too here is that we have linear motion over here, a little bit of rotational motion at the hinge, where the hinges come together. And of course this is a rotational motion, and you wouldn't know that because you have these minus signs over here in the feature manager. And unlike sketches, you don't really necessarily want those minus signs in there, which means it's underdefined. But in an assembly, if you want motion, yeah, you definitely want to see some of those minus signs in there. Doesn't mean that there's an error in there. It just means it's underdefined, and there's still motion that's capable in your assembly. So let's go ahead and put in our pins. And what this is really kind of fun to do. I'm going to go over here to my Windows Explorer through my computer and go to the folder that I want to that I have all these parts in. I'm going to go ahead and open up my pin, and we're going to get that in the screen. So we've seen this before. I'm going to take my pin. I'm going to go up here, and we're going to actually put that off to the right. We're going to make a window off to the right. And we're going to take our assembler, we're going to put that off to the left, just like we did before. And we're going to shrink this down a little bit. And I'm going to take my pen and rotate that around a little bit too, so we can see the very end of that. And what we want to do is we want to be able to grab that edge. And we're going to pull this over here a little bit too to make that a little bit bigger, so we can see where we're putting this in. So this is what we're going to do. We're going to take this pin and insert it into our model. Now you're probably thinking that, oh my god, we have all these pins to put in. We have 1, 2, 3, 4, 5, 6 pins to put in on this model, as many pins as we have hinge plates in here. And it's going to be very tedious putting this together. But let me show you a shortcut, which is kind of fun. It's very similar to SmartMates that they have with the Toolbox. But we can actually create SmartMates too, but we're going to save that for a different video. But here, if we were to grab this edge over here, which is, if you think about that edge, it's it shares an interface between something that could be concentric to something that could be coincident, a flat face to a curved face. If we were to take that and drag that over here like we've done before, and actually pick up this relationship over here, you'll notice that you see something that looks like a kind of like a blue marshmallow on top of a plane with a blue disc on it. What that is doing is it's going to concurrently give us a coincident and a concentric relationship. Concentric for the symbol on top, coincident for the symbol on the bottom. If you just drop that in there by selecting that edge, make sure you take your cursor and put it over that edge until you get it to look like that. Bang, puts it in place. So we could do 2 right away here. Big time saver. We're going to do the same thing over here. So we're going to take these 2 edges over here by grabbing that edge, grabbing this edge over in our graphics area in our assembly, and try to select that. It's not going to let us do it there. Oh man, what's going on here? So let's try that again. We're going to go ahead and drag this edge over here and try to define this edge. There we go. That worked there. And then we're going to do the same thing over here. We're going to put that in place. Now, in an assembly like this, we're going to do something like with simulation, and you want to get everything all locked down and where everything is fully defined. You're going to have to think about these pins here and fully define these pins. We're going to go ahead and fully define one of these pins, but not all of them just because of the work involved. But you'll see that they put it in place. But one thing to note about these pins is that they can still rotate. You can rotate that pin around a little bit. So what do you do with that? So what you want to do, I'm not going to do this with all of them, but we could take that pin, like maybe this last pin that we put in here, perhaps that one. We're going to go ahead and select the top plane of that pin, and we're going to take the top plane of the assembly, and we're going to mate that together. Now, the only reason you really want to do this, it's kind of nitpicking about the details, is if you want to do something like simulation to your assembly, that you need to make sure, or if in some other application you need to make sure everything is all fully defined. This is one way to do that. So we're going to pick those 2 top planes. We can't make those coincident, but if we go to mate, we can make those parallel. So we're going to go to parallel. It's going to snap it back. Initially, it was going to make it coincident, which would have collapsed our whole model. But we can make that parallel to the assembly. We could also make it parallel to maybe the hinge plate that it's connected to. But one way or the other, that's one way to almost fully define it. Of course, it's still going to be flexible because it's got to be movement with the hinge plates that are there. But it's one way to help define that a little bit better. So let's put in some more parts. Okay, we're getting close to the end. Let's make our next part in here our push rod, which is actually our next to last part that we're going to put in here, but the last part that's actually going to tie this all together and make it really functional. So yeah, a couple of ways we can do this is just go ahead and insert the component. We don't have it open. We do have the pin open, but let's go ahead and browse and look for that. This is going to be a push rod. So let's see if we can find it. There it is over here. If you go to open, we're going to go ahead and just drop that into place. Remember, if you drop that out there in an arbitrary location, it doesn't fix it unless it's the first part we put into an assembly. But it's just going to put it out there, and it's going to give us no mates there. So if you actually take a look at that and look at our mate folder in here, you'll notice that we do not have a mate folder, whereas that pin, which came before that, does have that mate folder. And we didn't talk about that before, but we put in that parallel relationship in there. That was last, but it automatically put in the concentric and the coincident relationship in there too. So let's go ahead and make our feature manager tree a little bit more compact. Let's go over here to the pen, and let's go ahead and turn this off, or just go ahead and suppress that, put that in the background, or just close it. And let's go ahead and maximize this again to our screen so we can see what we're doing. I think maybe the first thing we want to do is we want to go ahead and take this pin here as a way to mate this stuff. We're going to go ahead and select that front plane. So remember, as we put our models together, we want to keep that symmetry in mind. When we put this pin together, we made sure we did a mid-plane extrude from the very center of that pin. Now that's becoming valuable because we can put this push rod right on top of that. So we're going to take that front plane of that pin, scroll down a little bit, we're going to open up this, and click on the front plane of our push rod, and guess what? We're going to mate those together. Bang, we're going to put those together. Now, as an alternative to that, it puts it right on that plane, so it's able to translate back and forth on the x-axis, but it can't translate about the z-axis because it's got the planes put together in such a manner we have that coincident there. So you it kind of looks like it's going back and forth over here, but it's actually going front to back. So an alternative to that is to that mate, and we can take that mate and actually suppress that, just like we can suppress features and other elements in here. We're going to go ahead and suppress that. Another way of doing that is an advanced mate called the with mate. So this time we're going to initiate by going into the mate command first, and then we're going to go down here to advanced mates. We're going to open that up, and then we're going to have to go back up here and take a look at this. What it's going to be, what we're going to define that is going to be the with mate. So we can't really have that selection in here, so let's go ahead and delete that selection. Go back over here to with, and we're going to select two elements in our modeling area as part of the assembly, and then two elements in a part that we want to put exactly in the middle of that. So this is going to be one on the top hinge plate there. We're going to go ahead and select that surface, and then this surface over here on the hinge plate in the bottom. That's going to give us the two green selections. Now the two purple selections are going to be as part of the part. Of course, these could be flipped. We could do the part first, and then the push rod first, and we could do the hinge plate second. But here we're going to go ahead and choose that surface for the first selection, and that first surface for the second selection. You can see the slight adjustment. And now no matter what we do to our model here in the middle, if we're going to make that gap a little bit wider than it was before, this will always be in the middle of that. And if we go to the green check mark, now we have that in place. So while we're here, let's go ahead and select that circular surface and this surface of our push rod. Let's go ahead and make that concentric. So I think we're still in advanced mates, so let's go back to standard mates. And let's go ahead and make that concentric. And go to the green check mark. And I closed that a little bit prematurely, but let's go ahead and select these two surfaces here and mate those together. And now we're almost ready to go. So let's take this thing for a spin. Okay, let's take this for a spin as promised. Let's just spin that around and see what happens. Now, that's pretty cool to me. So you spin that around, and that goes up and down. This is rotational motion. That translates into linear motion, although a sine wave linear motion in a way. But if you look at that corner, you can see that that's actually going up and down. Rotational motion, linear motion. So that's kind of cool. And the neat thing about this is a very simple assembly. You put that together in SolidWorks, and you actually get to see how the assembly works. So there's a little bit of room for improvement in here, as you can see. The plates, these hinge plates, don't go all the way down. We could probably make this so that it functions a little bit better in that respect. But it also doesn't fold up in itself either. We can actually get pretty close to the top over here as this thing spins around. And the hinges over here are still a little bit bent. They don't bend on the inside, because if they did bend on the inside, then the whole thing probably wouldn't work as well. But the advantage of putting together an assembly like this is now you can see what you can do by looking into the graphics area in order to improve your model. It gives you that one additional graphic capability to be able to see, maybe improve on clearances or maybe change part sizes, do simulation, do some engineering in here in order to improve your assembly, because this stuff may not be as apparent when you're thinking about this sketching on a piece of paper, maybe just plain thinking about it. So definitely an advantage of putting something like this together. And of course you get to see the motion too. There's no way you can do this unless you actually go out and build prototypes to do something like that. So there's your assembly. Now we have one more part to put in here. Let's go ahead and do that. Let's go ahead and insert a component. We're going to be looking for the wheel guard, which is going to be this guy. So we're going to go ahead and open that. Now you'll notice that when we put this in here that it's still kind of lined up. That's one thing to keep in mind. In regard to the wheel guard, I anticipated that the front plane is going to be matching to the front plane of the assembly when I put this together. So it's already starting with a good orientation. If I just drop it out there in an arbitrary location, the properties manager disappears, and we're going to go ahead and insert some mates. So I'm going to click on that face and this face. We're going to go to mate, put that together. Now we're going to go ahead and take this surface here and maybe mate that to the top surface here. But remember, when we put this guard together, that we actually made room for the thickness of the plate. So here's a top plate. So between this line and that line should still be 3/4 of an inch. And this line would represent where the top plane is going to be. So if we're going to go ahead and X this out on mates and look at our last component that we put in here, which is going to be this guy. Again, we can take that top plane and the top plane of the assembly, which is a really good mate. Let's go ahead and scroll that up a little bit. try to grab that bar and scroll up to the top. There we go. Wasn't selecting easily. If we put that together and put those mates together, it's the same as taking the bottom of this wheel guard and actually mating it to the top surface of this. But nice thing about this is that if we just mate those two top planes together, it's a little bit easier, and it probably keeps the model a little bit more precise too. Of course, if we were to change the thickness of this, we're going to have to change the thickness of the wheel guard too. So maybe this line down here, and maybe this edge over here, I like it because it went transparent. We can actually select through it. We can mate those two together, and make those coincident or collinear. Collinear is what it's really doing, but it's making it coincident. And if you go to the green check mark one more time, let's go ahead and check this. And if we tug on that, it says selected component is fully defined. It cannot be moved. So now we have that in place, and I think this kind of completes our model up to the point where we're going to be putting in some tool box fasteners. We're going to be putting in some screws on the top, some machine screws on the top, some bolts on the bottom on our wheel mount, and now it'll give you an introduction to the toolbox. Okay, so let's finish up our model here. Let's go ahead and scoot out a little bit and kind of take care of these the sketch geometry on our wheel guard. Let's just go ahead and right click on one of those sketch entities in there and tell it to hide. So it kind of gets that out of the way. And what we like to do here is kind of put in some nuts and bolts in our screw holes here. So it's a good way to dress up your model, but it's also a good way to check for clearances on standard size fasteners you might be using on your assembly model. So SolidWorks gives you a really nice library of all sorts of fasteners and gears and bearings and other things in an item it calls the Toolbox. And the Toolbox is a folder of all these parts that have already been created in SolidWorks. And all you have to do is drop them in your model, and they're smart enough. They have smart mates on them, and we'll talk about smart mates in a different video. That you could actually drop them into place. It'll recognize a hole that they might be associated with or some other model geometry, and it's going to go ahead and select really close to the size you actually might want. So how do we get that toolbox? And it's, again, it's more like a tool room rather than a box because it has a lot of stuff in there. But if you go to Tools, scroll down, scroll down, you want to go to add-ins, and it's going to be one of these add-ins here, which is called the Toolbox library. You want to go ahead and double check that, or as an alternative, if you go to the design library, because that's where the Toolbox is ultimately going to reside, if you go ahead and click on Toolbox in here, and then you have the capacity to add it in right now. So either way, we're going to go ahead and add it in right now. And it's going to give you some folders that you can choose from. So Standards is the folder first. And you can go down here and pick the folder, or go up here and pick the folder, either way. But it's a little bit bigger down here. It's a little bit more graphic. So if you double click inside of ANSI Inch, which is going to be our folder, we're going to initially choose bolts and screws. And then secondarily, we're going to go ahead and choose nuts. And we could do washers too in here. It gives us that capacity. But nuts right now, or bolts and screws. We're going to go ahead and pick that first. We're going to pick up machine screws that are countersunk. So double click on that, and it gives us 3 different options. We get to do an oval screw or flathead screw with either a 100-degree angle or an 82-degree angle, and I believe our hole wizard hole is going to be a 100-degree angle. So let's go ahead and grab that. You don't want to double click on it, doesn't do anything, but if you drag it into our modeling area and kind of get it close to the edge that would define where that screw is going to go, it's going to go ahead and give us a relationship right away, a mating relationship. And if you rest your cursor over an edge or a surface in here that's curved, it's going to go ahead and pick up a concentric to concentric relationship automatically, as we've seen before in this assembly. If you drop that into place, it's going to recognize that and give us a suggestion on size. So right now it's giving us a 1/4 inch screw, 28 threads per inch. We can go over here to the Properties Manager and actually select more items, more options in here. We're going to talk about the toolbox a little bit more later, but the primary ones over here is going to be the size, which is the same you see out here in this this call out, and it's going to give us a length. Now the length or the thickness of our plate in here, of our bottom plate, is about 3/4 of an inch. So if we choose 3/4 of an inch here instead of the 1/4 inch, that might be convenient. It's a little bit elevated above that. And I like the size too. 1/4 of an inch will probably work pretty good too. So we can go to the green check mark there or in the Properties Manager and get that into place. So green check mark. Okay. Okay, we'll go to the green check mark over here. That one wasn't working. And when we do that, it actually gives us another screw. So now we can go to a different part of our model and put that screw in. So conceivably, and relatively quickly, we can go around our assembly and just drop in screws all over the place. Might have to come back a little bit later and redefine those a little bit better. But now it's going to go ahead and pick that in, and it's kind of backwards. And I believe you can correct that by doing the tab key. And yeah, there it goes. So tab key might get the right orientation. Otherwise, you can just take your cursor and kind of move that around a little bit until you actually get what you were looking for. And if it's actually reversed, you can go back and change that too a little bit later. So those screws are in place, and now we need to define those a little bit better. So remember, these are parts. These are parts already developed by SolidWorks. Just like any other part, we need to go in here and define this a little bit better. So we're going to go ahead and take this edge. It's going to be the bottom edge of that, the top part of the screw, and we're going to go ahead and click on this surface in here. We're actually going to mate that together. So it actually sinks that down right to the countersink, gives us a little bit of space up here, so so it isn't right up to that surface, but it's just a little bit below that. And then we're going to go ahead and click on this edge and that surface over here, and we're going to make that parallel. Now the reason we're doing this, if you go to the green check mark and green check mark one more time, is when we pull and tug on that, it says the selected component is fully defined, it cannot be moved, and that's okay. If you have an assembly you're putting together and you have a bunch of fasteners in that assembly and you need to use that assembly like in Motion Manager or in simulation or in some other application like maybe a sub-assembly, it's good to have all these things that don't need to move, unlike the hinge plates. If they don't need to move, let's go ahead and nail those things down so that they don't move. So a couple different mating relationships in there will get that defined. Okay, so let's take a look at this. Let's go to our Feature Manager tree and look at where those screws are. You'll notice that our first screw that we put in here, if you select it in the Feature Manager tree, it actually shows up as green in our graphics area or modeling area. And then this other one over here is green too, but just because we selected it, is not fully defined. So one's got a minus sign, bracketed minus sign, the other one does not. So this one's fully defined, and this one is not. So let's go ahead and define this a little bit better. And we can actually look at the mates in here too. Every one of these screws that we put in, both of them, have a mate folder in there, just like you would expect a part. It looks a little bit different. It's actually a little bit better defined. All the toolbox items in here kind of look like a bolt, as we see over here. But with that first screw in there, we have that concentric relationship, if you remember. A coincident relationship between the edge and that curved surface that defines that whole wizard hole. And then a parallel relationship with the front. We could do the same thing over here. So if we go ahead and take a look at this one, which is concentric, if we were to right click on that, if your screw actually gets put in upside down, if you don't want to break that relationship and redefine it, you could just go down here to mate alignment and change it that way too. So that's one way to do that. And if we go to the green check mark here, we can define this a little bit better. Again, this edge and that surface, we're going to go ahead and put that together. Green check mark, and maybe that edge over here and this surface over here. We're going to make that parallel and put that together too. So that's fully defined. And if we go to the green check mark, now we can do something a little bit different, but very similar. We're going to go ahead and put some bolts or some nuts in on the bottom. When we put our nuts in, we want to make sure that we select that edge over here. And again, it's going to recognize what's already there and suggest a size that we might want to use. So again, we're going to go back to our task pane, and we're going to go to our ANSI inch folder over here for our toolbox, and we're going to go ahead and choose nuts. We're going to go down here, we're going to choose a machine screw for the nuts and open that up, and we have a couple different choices. We have our hex screw, and then we have our square screw, or hex nut or square nut. But just like before, if we just drag that out here and try to pick up this edge over here, it's going to give us, if you select that carefully, it should give us a concentric and a coincident mate in there too at the same time. Sometimes it flashes and it doesn't look like it's going to be apparently going to give you that relationship. but it's giving you the size in here. So we're going to go to the green check mark. It looks like it lined it up just perfectly for us. So green check mark there, and then again it's giving us that nut in here that we can continue to populate our assembly with. So we're going to go ahead and choose that surface back here, and then we're going to do escape and get us out of that. So if we go back to those nuts over here in a feature manager tree and take a look at that, still says that, the icon looks like a screw. That's just a toolbox icon. But if you look at our mates in there, first one's got a concentric and a coincident relationship. That's what we want. And then second one's got that thing too. But one thing you want to probably want to do, like we did before, is you want to make sure that you have you want to make sure that this gets locked down a little bit. You don't want that thing spinning if you're doing a motion manager. It'd be almost impossible to get your motion manager to work correctly. So we're going to go ahead and choose that surface. This surface, mate, we're going to make that parallel by default. It's going to go to parallel because you can't make it coincident with those other mate relationships in there. And between this surface and this surface up here too, we're going to make that parallel. If we go to the green check mark one more time, those minus signs are gone, and now we have those in place. So we also turned off the sketch relations or the sketch elements in that wheel guard, but we could do that too. We actually got rid of those sketch relations in regard to the sweep path, but we can probably get rid of these too. So we're going to go ahead and click on that. We're going to tell that to hide, and now that pretty well cleans up our model and finishes our assembly. Okay, so this is our assembly, and if you remember when we started from the very beginning, just as a quick summary, we put together our Sarrus base plate. That was the first item in there. We made sure that we fixed it. Every first item you put into an assembly always gets fixed, but we deliberately made sure it was fixed at the origin, and that's important. So go back and cover that if you're not certain about that. Next thing we did, we put in was a Sarrus wheel mount, and we used 3 mate relationships in order to get that in place. Then after that, we put in our hinge plate, and we realized that when we put in our hinge plate, one side didn't fit all. We had to go back to our hinge plate and create various configurations of that hinge plate to ensure that we had our hinges and our hinge cuts on either side in the right location. Once we put that in place, then we went ahead and put in our Sarrus wheel, and then we started populating our model with our pins. So we put our pins in place. Remember, we had our pins on one side of our window over here, the assembly on the other. We borrowed a common edge between a concentric, potentially concentric, and a coincident relationship there. Dragged it into our model, made 2 real quick, made references right away, and allowed us to populate our model with those pins relatively quickly. Once we got those pins in place, we put in our push rod, connected the push rod to our wheel, put in our wheel guard, and ultimately we put in our hole wizard with the hole wizard holes. We put in our fasteners from the SolidWorks Toolbox.